What's up everyone, welcome back. Patrick here, moving on to another linear systems word problem. So let's say that you have two accounts that you invest in. Account A makes 3% interest per year and then account B makes 9% interest per year. How much is invested in each account in each of these scenarios? So notice that there's three scenarios. So this is actually like three different questions. Even though it's the same account, there are three different types of questions that can potentially come up. Just wanted to give you exposure on how there's different ways that this could be worded. So in scenario one, it says the total invested is $60,000 and you earn 5% interest. In number two, you invest $10,000 more in account A than account B and make $4,500 interest in total. And then number three, you invest $15,000 more in account A than double the amount in B. And then you make $150 more in interest in account A than 5/6 of the interest in account B. So let's start off with scenario one. I'll bring back two and three once we get to them. And before actually getting into any of the scenarios, I want to make just a general chart here. So we got account A, and then we have account B. And so I want to create expressions for, let's start off with the amount invested in each of these. And we don't know what the amounts invested are. That's what we're trying to actually figure out in each of the scenarios. So we'll let the amount invested in account A be X, and then the amount invested in account B be Y. And then notice we're also told how much interest each account makes. So what we can do is, if we know the amount invested in A and B, we can actually create an expression for the interest earned in each one. The interest earned in 1 year. So let's say that we invest $100 in account A, and then it earns 3% interest per year. Well, the interest of $100 would be $3. And how do we go from here to here? Well, we just took this and multiplied it by 0.03. Or if we invested 200, multiplied by 0.03, we would get 6 over here. So with that, the interest earned in account A, the expression is going to be 0.03 times the amount that you actually invested. And then same thing with account B, except account B makes 9% interest per year. So that's going to be 0.09y, like that. And so we're going to be using these expressions for each of these scenarios. So in scenario one, we're told the total invested is $60,000. So that means this plus that, X plus Y, has to equal 60,000 like that. And then we're told you earn 5% interest. So what they mean is that in total, you're earning 5% interest on the 60,000. So 60,000 times 0.05 means the total interest that you earn is $3,000. And the interest in account A and the interest in account B are these two expressions, so these two added up have to be 3,000. So we would do 0.03x plus 0.09y is equal to $3,000, like that. And now we have two equations, two unknowns, so we can use substitution or elimination. I'm going to use substitution. So what I'll do is I'll isolate for the x in the first equation. So x would be 60,000 minus y. And then I'll take this expression and sub it in for that x. So I'll have 0.03 times 60,000 minus y plus 0.09y equals 3,000, like that. And now notice we have an equation where we can just solve for y. So 0.03 times 60,000, that would give us what? 1,800 minus 0.03y plus 0.09y equals 3,000, like that. And then I'm going to bring this 1,800 over. So what we would end up with is negative 0.03y plus 0.09y equals 3,000 minus 1,800. When we bring it over, that would give us 1,000 200, like that. And this would end up being 0.06y equals 1,200, like that. Divide both sides by 0.06, or sorry, not 12,000, 1,200. Divide this by 0.06. And so from here, we would end up getting y equaling 20,000. So that's the amount invested in account B. And then to get the amount invested in account A, very easy, we could just take this and plug it in here, right? Because the total has to be 60,000. So we'd have 60,000 minus 20,000, which would give us 40,000 invested in account A. And then you could check your answer. So both of these added, notice that it is 60,000. And then if we take the interest of each, 40,000 times 0.03, 3% of 40,000 would give us what? That would give us 1,200, like that. And then 9% of 20,000, that would give us 1,800. And then notice when we add these two, we get 3,000, which is 5% of the 60,000 in total. So we could be pretty confident that these two answers are right for the first scenario. Now moving on to the second scenario, I wrote it out here. So you invest 10,000 more in account A than account B and make 4,500 interest in total. And notice I have this chart here that I wrote out in the first scenario, so we'll be using that for the second scenario as well. So it says you invest 10,000 more in account A than account B. So there's 10,000 more here than over here. So we can create an equation with that. We can say X, the amount invested in account A, minus 10,000 equals the amount invested in account B. Another way we could have wrote this is X equals Y plus 10,000. That's another way to express this. Or we could have said X minus Y equals 10,000, right? There's 10,000 more here than here, so the difference between them would be 10,000. You could rearrange this in any way. But I'm going to keep it like this. And then it says you make 4,500 interest in total, meaning the interest in account A is this, interest in account B is this, so them added up would give us 4,500, like that. And so we got two equations, two unknowns, and notice that y is already isolated, so I'm just going to take this and plug it in for y. So we would have 0.03x plus 0.09, and then this expression I'm going to put in brackets, so x minus 10,000, and then that's going to equal 4,500, like that. So we would have 0.03x plus 0.09x, right? We got to distribute this 0.09. 0.09 times 10,000 would give us 900, and this would be 4,500. Like that. I'm going to bring the negative 900 over, so we would end up with 5,400 on the right side. And then these two added up would be 0.12x, like that. And then notice we can solve for x. We could divide both sides by 0.12. And then when you do that in your calculator, 5,400 divided by 0.12 would give us 45,000, like that. So notice these 0.12s cancel out. So x would be 45,000. That's the amount that would be invested in account A. And then we could find the amount invested in account B. It's just going to be 10,000 less than that. So 45,000 minus 10,000, that would give us 35,000, like that. So that's the amount invested in account A, that's the amount invested in account B. And like we did before, you could take these and you could check your answers. You could plug them into the two equations that you had originally. Make sure that the left side is equal to the right side. Another thing I want to mention is that they can ask different questions here. So what we asked was the amount invested in each account for each of the scenarios, but they can easily ask something like, what's the total that was invested for this scenario? And then you would just take these numbers and then add them up, right? That would give you 80,000. So that could be an answer as well. So there can be different questions that can come up from these answers you get, but whatever questions they do ask, this would be the process to first solve for the amount that's invested in each account. Moving on to the third scenario, so you invest 15,000 more in account A, then double the amount in account B, and then you make $150 more in interest in account A than 5/6 of the interest in account B. So this scenario out of the three, I feel like it's going to be the toughest one. Notice I still have that chart written out here that we made in the first scenario. So let's try to create some equations. You invest 15,000 more in account A, then double the amount in account B. So if we double the amount in account B, and then add 15,000 to that, that's going to give us the amount invested in account A. So that's the equation, given these variables here for the first sentence. And then the second sentence, you make 150 more in interest in account A than 5/6 of the interest in account B. So if we take the interest in account B and take 5/6 of that, so 5/6 times the interest in account B, 0.09y, plus we add 150, that's going to give us the interest in account A. Right? You make 150 more in interest in account A than 5/6 of the interest in account B. So you got to read these sentences very carefully when you're creating these equations. Take your time here, because the algebra is, we've already had enough practice with the algebra. You know how to solve this. It's more so creating the proper equations, especially when you get something more complex like this. So read it really carefully. And then from here, we can just solve. So notice that the x is already isolated. So we could plug in this for this x value. So we would have 5/6 times 0.09y. Now 5/6, instead of 0.09, let's just put 9 here. Notice that this would end up being what? 45/6, which would simplify to, we could divide both the numerator and the denominator by 3. So we would end up with 15/2, which would give us 7.5. Right, so it goes from 9 to 7.5. So 5/6 times 0.09 gives us 0.075y, like that. Then we got the 150. And then I'm going to plug in, for the x value, this expression, like that. Another thing you could have done, if you didn't want to work with fractions here, you could have multiplied everything by 6. That would have got rid of this 6. Then you'd have 5 times 0.09y plus 6 times 150 gives us 900. And then 6 times 0.03 would give us 0.18. So we would end up with 5 times 0.09y plus 900 equals 0.18x. This equation and this equation are the exact same thing. So that's another thing that you could have done. Different ways to go about it. I'm just going to leave it like this here. So notice now we have an equation in terms of one variable. So we have 0.075y plus 150 equals, let's distribute over here. So we'd have 0.06y plus 0.03 times 15,000. That would give us what? 450? Like that. So now what I'm going to do, I'm going to bring the 0.06y over. So 0.075y minus 0.06y would give us 0.015y on the left side. And then the 150 I'll bring over. 450 minus 150 gives us 300. Like that. Divide both sides by 0.015. To get the y by itself, Y would be 20,000. So that would be the amount invested in account B. And then if we want the amount invested in account A, I feel like this one is the easiest to work with. We could just plug in this 20,000 here. So we'd have 2 times 20,000 plus 15,000, and that would give us X. So 2 times 20,000 is 40,000 plus 15,000 gives us 55,000. So that would be the amount invested in account A. And if they were maybe asking what's the total invested, you could add these up, right? As I mentioned, they could come up with different questions based on these answers here. But in this case, they just ask for the amount invested in each account. That's what the answers would be. And then you could check these, plug them in to both equations that you had originally, make sure left side equals right side. And then if it checks out, then you could be pretty confident that those are the correct answers.